Okay, let's do a revision, a quick one for pure physics students doing electrostatics. Okay, this is took me quite a long time, quite a number of sessions to teach because there are lots of things to explain. Okay, so I'll just go through very quickly what I did many months ago. Okay, so remember electrostatics. Okay, we are talking about, well, there are two charges, positive and negative charges, and neutral means there's equal number of positive and negative charges. Okay, neutral doesn't mean that there is not no charge. Okay, there is charges, but they are equal number. All right, anyway, so this is part I think should be quite clear to you. Okay, methods of charging, this is the main thing. Okay, the first one is friction. Okay, when you have two materials which are being rubbed together, what happens? Friction between the two surfaces separates the charges such that one becomes positively charged, the other will become negatively charged, as electrons are transferred from one material to another. Okay, so take note about this first process of friction. So for example, you got a cotton cloth, a polythene material, that polythene material will become negatively charged, whereas your cloth will become positively charged. Know how to describe this. So if you identify the situation where they are saying, okay, this is being rubbed with that, okay, or there's friction between these two surfaces, then this is a case of charging a friction, and you're going to use this to help you explain your answer. Okay, so the next one, and the huge one involved, is electrostatic induction. But before we talk about that, remember the reasons when you write in this chapter is always these two reasons. One, like charges repel, unlike charges attract, or electrons or negative charges always move from low to high potential until the potential difference is zero, or both have the same potential. Okay, you always use either one or number two reason here to give the explanation why certain things are taking place, right? So now when we talk about electrostatic induction, okay, this is a definition. The main thing here, you see the word without contact. So when you look at a situation, you see there is no contact, you can already start to think, okay, this is electrostatic induction, right? So what happens in electrostatic induction? Okay, it's always good when you explain to start off with a simple first few words or statement just to introduce a scenario. When the negatively charged rod is brought close to the sphere, this is brought close to the sphere, what happens? Okay, you know it's electrostatic induction, you can say electrostatic induction takes place, full stop. Okay, and then the procedure to go and explain, I did tell you before, remember, is ERO. What does E mean? Electron movement. Describe how the electrons are moving. Okay, electrons are not positive charges. Always remember, do not talk about how the positive charge move. Okay, then give the reason. Is it the first reason or is it the second reason? And then say the overall effect. Okay, what happens as an overall effect? What takes place? What you see happen? Okay, so when we talk about this, we say electrostatic induction takes place. First statement, electron movement. Electrons move to side A. So the electrons are all repelled away to side A. Okay, do not say the positive charges move to side B. Okay, you say that electrons move away to side A, okay, or the further side. You can always label your diagram A, B when you're explaining, makes it easier. So that's electron movement. Why? Because why? First reason, like charges repel. Okay, the overall effect, okay, don't stop here. We tend to just stop here and say, okay, I think I finished answering the whole question. The overall effect is what? That side A is negatively charged, side B is positively charged. Okay, if this was a little sphere, okay, which is easy to move, held by a string, this sphere, you can say side A is negatively charged, side B is positively charged, moves towards the rod and comes into contact with the rod. Okay, that is part of the overall effect. Okay, so look out for electrostatic induction. Okay, there's another case, okay, where we can talk about, okay, is by contact. When things are in contact with each other, let's say for example, this ball, okay, in this case we can carry on. We say this ball okay, was free to move, and as a result, it came into contact with the negative rod. Okay, now what happens when it's in contact, when it is touching by contact? So we can start again. When the negatively charged rod comes in contact with the ball, okay, what happens? Electrons move from the rod to the little ball, the little sphere here. Okay, they move there. Why? Because electrons move from low to high potential. They move from low to high potential. So electrons from here go over here. Because here is a higher potential, this positive, this negative. So this being high potential, the electrons go over here. And as soon as the electrons move over here, what happens? The overall effect is what? This ball becomes negatively charged. Okay? They become negatively charged because of the movement of electrons from the rod to the sphere. And instantly it gets repelled. Okay? Why? Because light charges repel. So again, I use the ERO when I explain. Right? Explain how electrons move over here, gave the reason, overall effect, the ball became negatively charged and got repelled away. Why? Because light charges repel. So using this guideline is always very useful. Okay, so take note once more. Electrostatic induction is not in contact, okay, with each other, but when it's contact, what happens? Okay, electrons can move from one body to the other body. Okay, all right. Okay, next page. Over here, when we talk about this, we talk about how do we discharge conductors, how do we discharge insulators, okay, passing it through a flame, the process of earthing. All this should be quite easy for you to revise yourself. Okay, then after electric fields, again this one much neglected. Students, they don't memorize the proper definition of electric field or electric lines of force. Okay, this is even worse. Okay, most people cannot remember this. Okay, they can explain the hard questions, but come the definition, not prepared, can't do it. Okay, so do remember to study your definitions. Okay, drawing electric field is an area which you should not lose any mark. Okay, you just have to be very careful when you draw. Do revise your work properly. Always remember it's a positive charge. Okay, your arrows point away from the sphere. Okay, draw nicely. You can use a ruler and draw. Okay, and draw it nicely. Equal number of lines on both sides. Okay, so go and revise yourself. Negative charge, the arrows go in. Okay, what happens when both are unlike charges or both are like charges? How to draw? Go and practice drawing yourself. Okay, and this part, testing of charges. Okay, this came out a long time ago. They asked experiment to how to describe the testing of charges. Just describe something over here, very simple one. Okay, you can read for yourself. Okay, the main thing in this chapter, and probably the one that requires the most studying, is the applications of electrostatics and the dangers of it. Okay, there are quite a few applications. One is a precipitator. Okay, that is this precipitator is able to remove dust particles, pollution, okay, from chimneys. Okay, how does it work? Okay, it's quite simple process, but again, this process goes through talks about the ideas of what happens when the dust particles come to contact with the negatively charged wires here. Okay, what will happen to it? Okay, you will gain electron. Why? Okay, because electrons move from a low to high potential. Okay, then the gas particles, the ashes become negative charged. You will be attracted to the plates here because unlike charges attract. Okay, you can revise this by yourself. The one which I don't like to study a lot myself is photocopying machine. Okay, this one, go and study, go and read through again everything. Okay, make sure you understand. Okay, and try to remember the whole process. The whole idea is that when you shine this light, okay, on the parts which are charged, they become discharged. So the part which remains charged, okay, the ink will go towards it because the ink, they put it opposite charge. So unlike charges attract, so they attract like that. Okay, so in brief, that is what happens, but you need to know the whole process. Okay. Then some are quite easy like spray painting of cars. Okay. Insecticide spraying, they are quite commonsensical and much easier compared to photocopying machine to study. And then the dangers, okay, this one they normally have asked many times, okay, for lightning rod. Okay, lightning rod, why do you have a lightning rod? How does it help to discharge the discharge the lightning down to the earth? Okay, the whole process. Okay, you have to go and make sure you know how to describe the whole process. Okay, likewise for refueling cars, okay, or aircraft or petrol tankers. Okay, all these you need to study. Okay, you need to go and read through again, make sure you know the process of each one of them. Okay, and then that's it for the chapter. Okay, but there you need a lot of practice, right? That's why we did quite a number of questions here. Look at the questions you have done. Okay, go through them, read through them, look at the mistakes you made. Okay, try not to repeat it and to avoid it. Okay, remember when you're answering questions like this, always use your keywords and key phrases. Okay, it's like this is a typical O-level question, right? You read the question, you look at the diagram, you see this is electrostatic induction. Okay, what happens? Positively charged rod close, electrons from the bottom of the rod and the leaf move up. Okay, why? Because they are, unlike charges attract. Overall effect, the bottom of the rod and the leaf are positively charged, and the leaf repels away because like charges repel. So something like that can be asked. Okay, which is not very difficult to explain. Okay, so be very careful. Okay, as you are practicing. So sometimes also you get a situation like this. Be very careful. Okay, if you don't just look at the diagram and say, okay, this electrostatic induction occurs. Okay, it's not the case electrostatic induction. Why? Because the ball, this speed ball, is already charged. So if you did not see this word, you'll be answering everything in the wrong way already. Okay, you'll be saying, oh, okay, the right side is positively charged, okay, or something like that. And then the left side is negatively charged. No, okay, the ball is charged. That means it's already charged, positively charged in this case. Okay, so and then you can explain from there on. So look and read the question. Okay, it may not be neutral in the beginning, it may be already charged. Okay, so again here, what happens? This positive terminal is connected to A. So as a result, what happened? Electrons from A move to the positive terminal. That's my electron movement description. Reason, because A is at a higher potential. Right? And as a result, A becomes positively charged. So this is not electrostatic induction, but instead this is a case where they are in contact, held in contact with each other by a wire. Right? So this question, when we did this, well, this one encompassed every process, okay, from electrostatic induction till they came into contact, and after that they discharged. Okay, the ball fell vertically down because the excess electrons went down to the earth. Okay, discharged down to earth through the water vapor, and then it fell because of gravity. Okay, so go through this, read through your own answers. Okay, so for this chapter, it's all about keywords, key phrases. Do use the correct keywords and key phrases. Okay, and avoid saying things like positive charge, move from this side to that side. Okay, using the wrong words. Okay, right. So that's a very quick revision, all done under 15 minutes. But it takes you some time to still have to revise and memorize the things here.